In the shop today, we have a 2000 Chevy Blazer with a 4.3-liter engine and about 165,000 miles on it. The owner is complaining of a check engine light, poor fuel mileage, and a code P0300 is set. P0300 is a random misfire code. The PCM, or Powertrain Control Module, calculates engine misfires by closely observing the speed of the crankshaft through the signals it receives from the crankshaft position sensor. Code P0300 means the PCM has detected a misfire or misfires, but the frequency has not yet reached a point where the PCM can call out a particular cylinder or cylinders as the cause. Our first step in this diagnosis is to determine which cylinder or cylinders are misfiring. The misfire could be caused by an ignition, fuel, or engine issue. The easiest thing to check on this vehicle is for an ignition or spark problem, so that's where we started. After starting the engine, we could immediately feel an intermittent misfire. An easy way to check for an ignition or spark misfire is by using a timing light or spark tester. We connected a timing light to each of the ignition wires and observed the light. If the cylinder is firing, the light should consistently flash in time with engine RPM, like this. When the light flash skips, like this, you've found a cylinder with a spark issue. All the other cylinders appear to have good spark. At this point, it looks like cylinder number 2 is the only one having a problem. We removed the spark plug from cylinder 2, and as you can see, it looks old, but it also looks like it still can fire. We then tested the number 2 ignition wire. Remember, the spec for suppression wires is no more than 8,000 ohms per foot. The wire going to cylinder 2 is approximately 2 feet long, which means it should not read more than 16,000 ohms. As you can see, when the wire is moved around, the resistance is going far above spec. Now that we found at least one of the problems, we'll replace all of the ignition wires and the plugs on this engine. In fact, because of the problems we've found so far, we're going to do an ignition tune-up on this vehicle, which will also include inspecting and possibly replacing the distributor, cap, and rotor. After inspecting and removing the distributor cap, we found another interesting issue. Look at the corrosion on the terminals inside this cap. This corrosion occurs because the moisture and excessive amounts of ozone trapped inside the cap. To understand why this happens, let's take a look at how the distributor, rotor, and cap are designed to function on this vehicle. When the gap between the rotor blade and one of the cap towers is jumped or bridged by an electrical flow, ozone gases are created inside the cap. Ozone's a powerful oxidizing agent, far stronger than just oxygen. High volumes of ozone in an unvented environment will rapidly oxidize metals. This is the primary reason vent holes, like these, are incorporated in distributors. A service bulletin for this vehicle says we should remove and discard the screens in these vent holes and blow compressed air through the holes to ensure they are open for proper ventilation. Look closely at the bottom of the rotor to see the design for one of these systems. The fins around the outer edge are there to promote ventilation and ozone removal. As the engine runs and the rotor turns inside the distributor, these fins are constantly pulling fresh air in through a vent hole and pushing harmful ozone gases out through the other. Notice there is no seal between the cap and the distributor. Some fresh air is also drawn in from this area and ozone is pushed out. When fresh air flows through the distributor, it is also a dryer to help reduce the accumulation of moisture. But the greatest amount of moisture gathering does not occur while the engine is running. It happens after the engine is shut down through condensation. When the engine stops running, the rotor stops drawing fresh air through the distributor. The ambient or outside air will cool at a faster rate than the warm air inside the distributor. When the distributor's ventilation is restricted, the warm air inside the distributor cap will cool very slowly, and because of the temperature difference to the ambient air, condensation will form on the inside of the cap. In cooler climates, this rate of condensation is greatly amplified. Through convective heat transfer, proper distributor ventilation allows the warm air to move out from the inside of the distributor and draw the cooler ambient air in, equalizing the temperature change and greatly dropping the possibility of any condensation. After a close inspection of the distributor cap, we noticed carbon traces leading from the brush area to cylinder number 4. Cylinder 4 is the closest conductor in distance from the carbon brush. As an example, when an ignition wire or spark plug deteriorates, causing high secondary resistance in the system, the coil's electrical charge is going to search for an easier path to complete its pursuit to ground. Due to the design of this cap, the easiest path is through the number 4 cylinder conductor inside the cap. Whenever you notice carbon tracking, it is critical to check ignition wires and spark plugs for wear. We removed the screens and cleared the ventilation ports on the distributor. We replaced the rotor, ignition wires, cap, and spark plugs, and we cleared the code. We took it for a test drive, and it's running smooth, and the P0300 code didn't return. Remember, when a P0300 misfire code sets, it could be an ignition, fuel, or mechanical issue. The first step in the diagnosis is to determine which system has the problem. That's it for today. See you again next time in the Wells Garage.